the fan. We're now going to take a look at how electricity makes the basic fan work. This white fan head is from a pedestal fan, just like this one. Before we can show how the fan wiring is done, we have to remove the motor from the housing. Turn the 4 clips into the open position and the fan blade cover can be removed. Turn the blade lock nut clockwise and the fan blade can be removed. Under the fan blade, you will see another lock nut. Turn this one anti-clockwise and remove it. Now there are 4 screws on the front of the motor housing that must be removed. This will allow the plastic motor cover to be removed. Please use a container for your loose screws. There are 5 plastic clips that need to be depressed and the locking clip pushed in. At the back of the housing, there is a screw holding the motor in place. Remove this screw. The fan rotating knob also has a screw inside the knob. Remove the screw and the motor will come out of the housing. This AC on the live wire is taken through some filtering components straight to the switch. This is a 3-position make-break type of switch, and we'll explain a little bit later how this one operates. The motor used in a basic fan is a single-phase AC induction motor. The operation of this motor is explained in the motor video. Let's look at the AC coming in from the power lead. The live wire is routed straight to the on-off switch. The switch used here is a 3-speed switch. On the output side of the switch, the selected live position will route the live to one of the 3 wires. Here we see the blue, white, and red wires. These are wired to the main winding, but at 3 different places. 1/3 of the winding, 2/3 of the winding, and finally the full winding. Ohm's law tells us that as the resistance increases, the current flowing will decrease. Our power formula is power equals voltage times current. The AC voltage is constant at 230 volts, and so as we decrease the current, the power will also decrease, and therefore the speed of the motor. The neutral or common is routed via a connector and into the motor itself. The neutral, therefore, is common to both the main and the auxiliary windings. There is almost always a thermal fuse on the neutral wire, and this fuse is attached to the side of the stator winding, and it will blow if the motor gets too hot. Because the fuse is on the common wire, this means that neither the main or the auxiliary windings will get AC power. There are also 2 black wires brought out from the auxiliary windings, from the motor to the starting capacitor. Now let's take a look at how you test and repair the fan. The most common problems are a blown thermal fuse. If you measure between the live and neutral pins of the fan plug, you should get about 1020 ohms for speed 1. ,970 ohms for speed 2, and 800 ohms for speed 3. If you get 0 on all 3 positions, it's more likely that the fuse is blown. It is possible that the neutral is disconnected at the connector, but this is rare. Changing the fuse is very difficult, but it is possible. If one or more of the speeds do not work, then it's clear that there is a disconnected live connection, either at the main winding or at the switch. This can be checked by measuring each of the live wires of the switch. Measure the 3 live wires, red, white, and blue, at the switch between each of these at the neutral connector. If you measure the 3 main windings of the plug, but when you switch on the fan it does not rotate, then the problem is at the auxiliary windings. Either the winding itself is disconnected, or most often the start capacitor is faulty. Please take care to select the correct capacitance when installing a new capacitor, as there's a strong relationship between the inductance of the auxiliary winding and the start capacitor. Changing the value alters the speed of the motor. Fans attract a lot of dust, and this dust settles on the blades and also the rotor bearings. Regular cleaning of the motor is advised. Do not put oil in the bearings until you have cleaned the motor thoroughly, as the dust and oil creates a sticky mess, which retards the rotation. Some fans have a mechanical device which moves the fan left and right. This is accomplished by a series of gears inside a small plastic enclosure. Either the rotation arm or the gears might break, stopping the sideways motion of the fan head. Electricity is dangerous. When working on any electrical appliance, remove the plug from the wall socket.